Good morning, kiddos. Today we're going to be talking about TEK 8.10D, modeling the effect of dilations on linear and area measurements. As always, please feel free to stop, pause, rewind, do whatever you need to do to make sure you're understanding today's lesson. So for our goals today, we're going to know how to investigate the effect of a dilation on the perimeter and area of a two-dimensional figure. We're going to be able to model the effect of a dilation both numerically and algebraically, and then we're going to understand why and how the figure is affected. So here is some vocabulary that we're going to use. This is the vocabulary. It's not the only vocabulary in this TEK, but it's the most used vocabulary. So for area, we have measures the space inside of a shape. Perimeter is the distance around the outside of a shape. Dilation is a transformation that produces an image that is the same shape as the original but is a different size. The scale factor is the ratio of any two corresponding lengths in two similar geometric figures. The pre-image is the original that you perform before the transformation. The image is the result of performing a transformation, meaning it's after you do the transformation. The dimensions is the measures of the size of an object, such as a box, and it's usually given as length, width, and height. And the corresponding sides are objects that are those that appear in the same place in two similar situations. Let's go on. So first we're going to find the perimeter in a dilated figure. So basically to find the perimeter, all you're going to do is the perimeter of the dilated figure is going to be the perimeter of the original figure or the pre-image multiplied by the scale factor. So all I would need to do is find the perimeter of this pre-image and then multiply it by my scale factor, and I'll get the perimeter of my image. But let's look at it down here. So the perimeter of my pre-image, remember that perimeter formula is 2L plus 2W, right? Meaning 2 times L and 2 times W. So my length is 4, my width is 6, and when I do put that all together, I get 20, right? 2 times 4 is 8, 2 times 6 is 12, 8 plus 12 is 20. Now the perimeter of my image is same thing, 2L, 2W. So 2 times 8 is 16, 2 times 12 is 24, 16 plus 24 is 40. Now, if you compare the two numbers, 20, we got 20 as the perimeter of our pre-image and 40 as our perimeter of our image. If you compare the two, you'll see that our scale factor is again 2, remember? Now, all we needed to do was to multiply the scale factor of 2 by the perimeter of the pre-image, which was 20, and we would have gotten 40, right? So yeah, that's all you needed to do. Remember, whenever a figure is dilated by a scale factor, the perimeter of the figure changes according to the same scale factor, okay? Here is a time I want you to pause in the video and try to figure this out on your own. All right, so if you got, well, let's just work it through, okay? So all we're gonna do, again, is we're gonna find that, we're gonna find the perimeter of the rectangle, right? So we'll do 36 times 2, you should get 72, and then 12 times 2, you should get 24, and then you'll add those two together, 72 plus 24, and you should get 96, right? Then all we're gonna do is do 96 times 1/2, right? And you should get 48, okay? Moving on. So we're going to find the area in a dilated figure. The area of the dilated figure is a little bit complicated, but it's not. Just pay attention to what you're doing, okay? The area of a dilated figure is the area of the original figure multiplied by the square of the scale factor. So I'm going to take my scale factor and square it, meaning to the power of 2, and then I should get the area of my new image, right? So let's look at it. The pre-image we have right here is 4 times 6, because length times width, and we get 24. And then the area for my image is 8 times 12. 8 times 12 is 96, and because that's all you do, length times width. Now, all I have to do is take 24 and multiply it by 2